here together we have our good chemistry question. 10 cubic centimeter of hydrocarbon Z was exploded with excess oxygen, and on cooling to room temperature there was a contraction of 25 cubic centimeters. On addition of concentrated sodium hydroxide there was a further contraction of 30 cubic centimeters. All volumes were measured at room temperature, so our task is to determine the molecular formula of Z. Here I've worked it out and I've got the molecular formula of Z. So first and foremost we need 3 volumes. We need the volume of hydrocarbon Z. We don't write hydrocarbon Z, the full word, but we write the general formula for hydrocarbons, CXHY, that one. Then our volume for hydrocarbon Z, we have been given 10 cubic centimeters. That one we have it. Volume of oxygen reacted we don't have. Then volume of carbon dioxide formed is 30 cubic centimeters. This 30 cubic centimeters was formed when sodium hydroxide was added. We all know that sodium hydroxide removes carbon dioxide. So after adding sodium hydroxide, carbon dioxide was removed. That is the second contraction for 30 cubic centimeters. And another thing, we need a volume of water formed. Volume of water formed is not crucial, but in this question we have been given the volume of water formed. That was the first contraction, so it is 25 cubic centimeters. Then from there we write our general equation for combustion of hydrocarbons. So general formula of hydrocarbon, CXHY plus X plus Y over 4 in bracket, that is moles of oxygen, which is a gas. We get X moles of carbon dioxide, which is a gas, plus Y over 2 moles of water, which is a liquid. So we have 10, which is the volume of hydrocarbon, and volume of oxygen we don't have it. We have volume of carbon dioxide, we have volume of water. From there we calculate to get volume of oxygen. I told you we need 3 volumes. Volume of hydrocarbon Z, CXHY, volume of oxygen, and volume of carbon dioxide formed. To get volume of oxygen, you say volume of hydrocarbon Z, which is 10, plus an unknown volume of oxygen V. You have to get the volume of carbon dioxide 30 plus volume of water 25. When you solve the value of V, you get it as 45. From there we again write the general equation for combustion of hydrocarbons. After writing the general equation, bring the volumes back. Volume of hydrocarbon CXHY, that is hydrocarbon Z. We have volume of oxygen, we have got it. We have volume of carbon dioxide. These are the vital volumes in eudiometry. So from here we express volumes in terms of moles using Gay-Lussac's law, or Gay-Lussac's rule, that when given volumes you can express volumes in terms of moles. So to express the volume of the reactants and the product in terms of moles, we divide by the volume of hydrocarbon Z, CXHY. The volume is 10. Divide throughout by 10. We get 1 mole of hydrocarbon CXHY. Here on oxygen we get 4.5 moles. on carbon dioxide we get 3 moles. From there, again Gay-Lussacker's law says that after getting the moles, relate the moles to the coefficients of the reactants and the products. Then we begin with X. Remember, our hydrocarbon is CXHY. We need this X and we need Y. From there, our X is 3. When we observe carefully here, our X must be equal to 3. From there, we have X is equal to 3. Then, to get the value of Y, we go to the reactant side of oxygen, which is X plus Y over 4 moles of oxygen. So, say X plus Y over 4 is equal to the moles that we have obtained, 4.5. Value of X, we have it. So, we say 3 plus Y over 4 is equal to 4.5. When you solve carefully, value of Y you will get 6. After getting 6, bring back our molecular formula, which is CXHY. We are finding the values of X and Y to have a complete molecular formula. We have got our X as 3, our Y as 6. When you feed an X which is 3 here, and you feed our Y which is 6 here, you end up with this. So this is the molecular formula of the hydrocarbon Z. You see, the question is solved. So just simply follow those steps, you will arrive to the answer. Thank you for viewing. Thank you so much. Thank you so much. This is the complete working of the question.